Hey everyone, welcome back to my channel. Have you ever wondered why we have day and night, or why the sun rises in the east and sets in the west? It all comes down to one simple yet fascinating phenomenon, the Earth's rotation. In today's video, we will explore how our planet's spin creates the day and night cycle, why it is crucial for life on Earth, and even how it impacts the weather and time. The Earth's rotation on its axis is a fundamental process that has a profound impact on our daily lives. It dictates the cycle of day and night, influencing weather patterns and contributing to various natural phenomena. The Earth rotates around an imaginary line known as its axis. This axis runs from the North Pole to the South Pole, and the Earth spins around it like a top. The rotation is counterclockwise when viewed from above the North Pole, meaning the Earth rotates from west to east. This rotation is why the sun appears to rise in the east and set in the west. The Earth completes one full rotation approximately every 24 hours, a period known as a day. The solar day is the period from one noon to the next. It is about 24 hours long. The phenomenon of day and night is a direct result of the Earth's rotation on its axis. The Earth's axis is tilted relative to its orbital plane around the Sun by approximately 23.5 degrees. This tilt is crucial for the occurrence of seasons. As the Earth orbits the Sun over the course of a year, different parts of the planet receive varying amounts of sunlight. When the northern hemisphere is tilted towards the sun, it experiences summer with longer days and shorter nights, while the southern hemisphere experiences winter with shorter days and longer nights, and vice versa. During the daytime, a specific region of the Earth is oriented towards the sun. The sunlight illuminates that part of the planet, creating daylight. The intensity and duration of daylight depend on several factors. The latitude of a location significantly influences the length of daylight hours. Areas near the equator experience relatively consistent day lengths throughout the year, while regions closer to the poles experience more significant variations. Latitude refers to the imaginary lines encircling the Earth, which run parallel to the equator and perpendicular to the Earth's axis of rotation. The equator, positioned at 0 latitude, divides the Earth into the northern and southern hemispheres. The poles, at 90 degrees north and 90 degrees south, represent the extremes of latitude. Near the equator, the length of day and night remains relatively constant throughout the year, with approximately 12 hours of daylight and 12 hours of darkness. This is because the equator is not significantly tilted towards or away from the sun during any part of the year. At the poles, the variation in day length is extreme. During the summer solstice, the poles experience continuous daylight, known as the midnight sun, where the sun does not set for several weeks. Conversely, during the winter solstice, the poles are plunged into darkness for an extended period, a phenomenon known as polar night. The Earth's atmosphere can affect how sunlight is scattered, which can slightly extend daylight hours through phenomena like twilight. As the Earth continues to rotate, regions that were once bathed in sunlight gradually turn away from the sun. This transition into nighttime occurs when these areas move into the Earth's shadow. Without direct sunlight, the sky darkens and stars, planets, and other celestial objects become visible. The transition between day and night is not abrupt but gradual. The periods of sunrise and sunset occur when the sun is just below or above the horizon. During these times, the sun's rays pass through more of the Earth's atmosphere, scattering the light and creating a soft, diffused glow. This period of light, known as twilight, provides a gradual transition between daylight and darkness. The Earth's rotation originated from the way the solar system formed. About 4.6 billion years ago, the solar system was a vast cloud of gas and dust. As this cloud collapsed under its gravity, it began to spin. As the cloud contracted, it had to spin faster. As the Earth formed from this spinning material, it inherited this rotation. Over billions of years, the rotation has slowed slightly. This is due to gravitational interactions with the Moon, but the Earth continues to spin on its axis. The rotation of the Earth also influences wind and ocean currents through the Coriolis effect. Because the Earth is rotating, moving air and water are deflected. They deflect to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection helps shape weather patterns and oceanic currents. The Earth's rotation is the reason for the establishment of time zones, since different parts of the Earth experience daylight at different times. The world is divided into 24 time zones, each approximately 15 degrees of longitude apart. This division ensures that local time corresponds roughly to the position of the sun in the sky. Earth rotates faster at the equator than it does at the poles. Earth is wider at the equator, so to make a rotation in one 24-hour period, equatorial regions race nearly 1,600 kilometers per hour. Near the poles, Earth rotates at a sluggish 0.00008 kilometers per hour. Why don't we feel the Earth spinning? You, your friends, the buildings, cars, and even the air around you are being held together by Earth's gravitational pull. Since the Earth rotates at a near constant speed, it doesn't speed up or slow down in any way noticeable to us. We simply spin with it and don't feel a thing. Thanks for watching this video. For more science videos, subscribe to my channel and hit that like button.